And welcome to episode 127 of the Actual Astronomy Podcast, the all about finding stuff in space edition. Sorry about that, Shane. I think I surprised you there with the recording, but we'll just roll with it.
Yeah, I'm locked and loaded. I'm always ready.
Good stuff. Well, we're amateur astronomers who love looking up at the night sky, and this podcast is for anyone else who likes going out under the stars. And again, my apologies. I'm a little tired today. I was actually out doing astronomy all night last night until it started getting bright. And as I was telling Shane, I came home and our carbon monoxide or carbon dioxide or one of these detectors ran out of batteries about half an hour after I had fallen asleep. So even though I was up all night, I was up bright and early and ready to go. So Shane, let's talk about finding stuff in the night sky. That always presents a challenge, not only for newcomers, but even last night I was struggling to find a few things. So yeah, what are your thoughts on this topic?
Well, if I remember when I first got into astronomy, in terms of like I bought my first real telescope, that was the most intimidating thing for me. Was like, how do I find anything in the night sky? Because at that point, everything basically looked the same to me other than the moon. It was just a bunch of different brightness of stars, essentially. And even though some of those stars were planets and other objects, but you start off with some basic understandings, and you just sort of work your way up to more and more challenging things. And I think we'll walk people through that today, and talk about some of the tools that you can use. We'll talk about some good books that people can use. And maybe to kick it off, I would say the first thing to start with to find in the night sky with a telescope or with binoculars is the moon. It's the easiest thing. And often, when we do our monthly podcast about objects to observe in the upcoming month, there's often a number of planets and sometimes some other deep sky objects that are, really close to the moon. So, locating the moon, you can kind of branch off and end up finding other things from there. But anyway, that's usually that's how I did it. Actually, when I had my first telescope, which was an 8-inch Skywatcher Dobsonian, it sat unused for a couple of weeks because I wasn't sure exactly how to use it, how to find something. Mm-hmm. And then one night the moon was out, and that was the first object I found through my telescope.
Nice. Yeah. Nice. Yeah. First thing I looked at was the planet Mars.
Oh yeah.
It's sort of similar situation. It was the brightest thing. It was a Mars opposition, and it was very high overhead, and we had these clouds that were just, it was very, very terrible conditions. And if you weren't somebody who was getting a telescope for the first time and only had this one night to use it, you probably would never have gone out on this night. And I was actually not sure it wasn't going to rain. And I remember I could see it between the breaks and clouds. Sometimes I could actually see it through the clouds, weren't that thick. And so, I was able to get it in there, and I was really surprised to be able to see it, even with our clouds going by, and I could see the polar caps and everything. Yeah, it was just amazing to be able to see that. Yeah,
that's a great first view through a telescope for sure.
Yeah, and sort of fortunately, of course, it was about the only thing I could see because of all these other clouds. So it was very easy to figure out which one up there was Mars. But yeah, I mean, and then sort of beyond like those early initial steps, it can be challenging to sort of make our way through the night sky. But probably one of the best places to get started is really just to begin learning those constellations. So how did you learn the constellation, Shane? And do you have any sort of tools, tips, or tricks for people who just want to learn those constellations really to get started?
Yeah, probably the best tool that I can recommend, and it's one that I've used and used for many, many years, and it's known as a planisphere. So a planisphere is something you can take into the field with you, and it has trying to explain this. It's best to probably do an internet search on this thing or YouTube video just to get an idea of what I'm talking about. But basically what it is like a piece of plastic or cardboard, and there's a central disc in it which rotates. And this disc has illustrations of all of the constellations in the sky. And then on the outside of the disc are dates and times. So what you do is you match up, like you rotate this disc so that it is the correct date and time for your current location. And then what you do, there's like north, south, east, west on this planisphere. You put it overhead and you hold it up to the sky, aligning, north to north, and then it provides a map of the night sky at that time for your location. And that's, to me, one of the greatest ways that you can learn the constellations. There's all kinds of apps out there that you can get on your phone, and it uses like the gyroscope in your phone. So you hold the phone up to the sky and it kind of shows you where everything is. I've used those kind of, like, I don't have a lot of usage time with those, but I have used them in the backyard. They're okay, but sometimes I find like the scale isn't quite represented very well, or what my phone is showing is not really aligned with what is in front of my eyes in the night sky. Maybe it's off to the right or off to the left. So I'm not as huge a fan of the apps. I really like the planisphere. And the typical thing too, I guess, with constellations is usually they're comprised of some of the brighter stars in the night sky. So, you look for some of those distinct stars, and then you start to draw the lines, in the sky to understand, the outline of the constellation.
Yeah. And I have to underscore, we use, planetarium software and other things for planning our sessions. And, I'll even create my own star charts from them and print them off physically and take them into the field. But there's a few challenges with using screens under the night sky. One of them is that the screens, at least all the screens I've seen, are too bright.
Yeah. They're often fairly bright. Now, there's some things you can do to tone them down. Like there's settings on the phone that allow you to put like a red background on and really tone down the brightness. And you can even get like red overlays to put on the display of your phone so that, it's greatly reduced. But the thing is it's usually such a large surface emitting light that it's kind of hard to really control. Now, if you're in the backyard, if you're in a light polluted sky, I don't worry too much about phones or any of that kind of stuff, because you're probably not getting that dark adapted anyway. But if you are outside, like if you've made the voyage to go to a dark site, I just don't like to spoil it with any kind of light, as little light as possible.
Yeah. And, as well, like we were saying, and I've helped a few people out with these, and it is always a little bit frustrating where if the software isn't set up properly, just like with the planisphere, you kind of have to set the day and time and have the general location and that sort of thing. But typically you'll buy a planisphere based on your latitude. So like you can get one for like 50 degrees north, which is more or less where we live here in Saskatchewan. And that will work more or less pretty much anywhere in North America, give or take. However, you can get ones for 40 degrees north, which is great if you live like in New York, or you can get ones for like 30 degrees north, which is great if you live in the southwestern states in the U.S. or something like that. And then there's all kinds of different ones that you can get, and that works really well. So that kind of bit of the setup is done for you. Whereas with the phones and the other apps, I often find that people haven't put something in right, or they haven't put the Greenwich Mean Time in right. So it's not correcting for when it's night here versus when it's nighttime in the UK, and of course that doesn't work so well. And they're kind of getting different constellations up, and it seems like that would be a simple thing to do, but with electronics in the night sky, like I was working with my, I have a computer-driven mount that can both work computer-driven and not computer-driven. And I was doing some finding of things last night, and I thought, wow, like I know where these things are, and I know what stars I need to have it pointed at to get it aligned properly. And that's pretty easy for me to do, but oftentimes for newcomers, those are going to be some pretty large barriers for getting into it. So that's why we recommend sort of these older sort of analog, just a plastic or paper planisphere, and then just kind of learning those constellations first before trying to get into this computer driven technology.
Yeah, for sure. Maybe I'll just take a pause here and maybe explain the process as well. So, if you're taking a telescope out under a dark sky, or even maybe a light polluted sky, um, usually what you're going to do, and I'm going to make an assumption here that you're manually moving the mount yourself. It's not one of the computer driven ones.
Yeah.
So, if you're doing this, usually the way you begin is well, first of all, you want to know what you're looking at, and we'll get into how you determine that. But once you have the object that you want to look at, you're now probably going to star hop to it. So you start at brighter stars that you can see with your naked eye, and then you use the telescope and you move from star to star to star until you get to the object that you want to look at. Now, that's why identifying the constellations is important, because you can often use one of those stars in the constellation to begin your star hop from. So, starting off with the planisphere, you're able to locate the constellation, then you can locate the star within the constellation that's important to you. And then you can start to navigate to some of the, nebulas, galaxies, clusters, whatever you might be chasing down within that constellation.
Right. Yeah. And even like, even some people may want some even more basic advice. One thing that I typically go over in my astronomy classes, my very basic non-credit university astronomy classes that I teach beginners trying to learn the night sky, is this great resource at skymaps.com. I'm not affiliated with skymaps.com. I'm not really, I don't know everything about them, but it's a reputable site. And what they do is every month they put out a free star chart that you can print off. And what they do something really well. And that's that they help you learn all the different bright stars and constellations using the moon and where the moon is in the sky. We'll say, okay, like the moon is going to be near Regulus, or the moon is going to be near Antares tonight. And on the left column, just about every day, it has where the moon is listed or where other things are listed, and what else is going on in the nighttime sky. If there's a meteor shower, something like that, all these really basic things. And I actually think if somebody did this, if somebody really wanted to learn the night sky, and you didn't have a lot of time, you could probably print those off and just take like 15 minutes or half an hour a month and go out with it in your backyard. And you could probably learn the sky over the course of a year or two. Just using that, it could be a lot of fun.
Yeah, that's a great suggestion.
So what else do we have? There's some other basic books I think that can really help people get going in learning the nighttime sky. I don't know if you had any sort of early books that kind of help you trace out the constellation chain, or any advice for tracing out the constellations other than using a physical planisphere and not relying on trying to drag out phones and iPads, which also are expensive. And like last night, it's extremely dewy, and you wouldn't want to leave an iPad sitting out for 3 or 4 hours in those conditions. It would probably be damaged.
Yeah. One book that you and I have talked about on previous episodes of this podcast, and is near and dear to our hearts, is Night Watch by Terrence Dickinson. That's one that I started off with early on, and there's multiple revisions of this thing. But even if you find an old one at a used bookstore, which is actually what I did, I think my first copy of that was like $2 or something like that I got at a used bookstore. And the thing is the constellations basically don't change.
No.
So it's still valid. And it's an awesome guide, to the constellations and some of the prominent things within those constellations.
Yeah, and what I like most about Night Watch is Terrence Dickinson, who's the author. He has this very great way of teaching people the night sky. And that book has these sets of charts sort of by season. There's sort of like 4 of these main seasons in the year, just like there is the seasons that we experience. And by seasons, we're talking about different stars that appear in the nighttime sky, depending on whether it's winter or spring or summer or fall. And he's got this beautiful bit in there, sort of well-drawn charts that depict what the sky looks like just to your eye with those bright stars. And then on the other page, he details out a bit of a chart, sort of allowing you even like sitting in your living room on a stormy night, to look and go back and forth and kind of become familiar with looking at the stars sort of in a natural way. Of course, when we look up, there's no lines drawn in the sky. Although sometimes I always like to joke and say it was so dark we could see the lines connecting the constellation patterns. But you don't see that on the nighttime sky, and of course that's part of the joy of learning this. And he really does that well. And then so he has these basic scents that help you see the sky just as your eye would see it. And then you can take those out under the nighttime sky, and the book is designed, it's ring bound, so you can lay it flat somewhere on like a car hood or something like that. And then he's got some more advanced charts in there, which actually depicts some of the brighter deep sky objects. And the other thing he does is he connects all of the star patterns, because oftentimes, and although this is less true now, but oftentimes in the past, star atlases would not connect the brighter stars that depict the most common star patterns, and that can be a bit of a barrier to people trying to learn the nighttime sky. If it's just like dots on a page, like what am I looking at, right?
Yeah, it's a really, really good book for all of those reasons. Is there any other ones that stand out to you, Chris, that are good for somebody just getting going?
So this is one I bought recently. It's another Terrence Dickinson book. It's even more basic, and it just goes to show that everybody learns a little bit differently. So he actually has a really, really basic one called Exploring the Night Sky by Terrence Dickinson. So this one's really inexpensive. I think I paid $9 for one new off Amazon. But anyway, in that book, he breaks the sky up into, I think, 5 or 6 different sort of dominant sets of constellations by sort of typical times of the year. So for example, you might even say like early spring and late spring and early summer, late summer. So I think there's maybe even up to 8 sets of these patterns. I have it here. I just don't want to flip through it. And people that were taking my astronomy class were actually getting this. I wasn't recommending it, and so I bought a copy. My spouse, she actually learned the night sky when she was doing her girl guiding, and she learned the stars and those patterns using this. And it's good. It's just that section isn't very big, and it's an inexpensive book. It's almost like a really good pamphlet. Almost, it's pretty thin, but that section in there is really nice. I kind of wish that they would pull that out and do something a little bit different with it. But in Night Watch, he expands on that a little bit more. But I think Exploring the Night Sky, if somebody was really just a rank beginner and looking to get very basic guidance on learning a few things, that book has something really basic that you can pick up and kind of read the pertinent sections over the course of an hour or so, like a very relaxing evening, having a cup of tea. And then one of the other books, and this is one I do own, and I have owned for a while, is by the author of the Curious George book. Strangely enough, H.A. Rey was also an amateur astronomer, and he actually worked to create better depictions of the star patterns that we see. And now they're a little bit different maybe than the ones you and I are more familiar with. He drew in a few extra lines, but by simply going out with that book, and it's almost like in workbook format, like the workbooks we used to get in grade school. And by using that book and kind of tracing out those patterns, you can become more familiar with sort of those dominant patterns, like the keystone of Hercules and the square of Pegasus and the W pattern of Cassiopeia and all that stuff. It really focuses on the ones that are a little bit in the patterns, and making those patterns that are a little bit more easier to recognize than maybe some of the other patterns that have been talked about previously, and those have been sort of adapted over time. So, yeah, do you have any other recommendations there for people just looking to get started and finding stuff in the night sky, Shane?
No books or anything like that, but I think we probably should move on to the next step in the process, which is there's a whole bunch of stuff up in the sky to look at.
Yeah, what do you look at?
Yeah, how do you even know what to look at? Let's say, for example, you want to look at a galaxy. How do you find where the galaxies are? So there's a number of observing lists, and maybe not even lists, but I guess maybe there's catalogs. So catalogs of objects in the night sky, and there's multiple different ones. There's the NGC, IC, Malott. There's a whole bunch of different catalogs out there. And then what people do is create observing lists, usually out of those catalogs. Now, probably the most famous observing list, at least I think, and correct me if I'm wrong, but it's the Messier observing list. And it's 110 objects. Most of them are quite bright and somewhat easier to find. And it's the quick history of that is Charles Messier was an astronomer that was looking for comets a long time ago. And basically what he would do is scan the night sky with his telescope. If he saw something that was fuzzy or diffuse, he would kind of chart the star field, and then he would come back a few days later and reobserve it. If that fuzzy thing moved, then he discovered a comet. If it stayed static, it wasn't a comet. So I think he ended up discovering like 6 or 7 or 8 comets in his lifetime. But what he's really famous for is this list of non-comets. And a lot of astronomers, a lot of amateur astronomers start off observing that list because of, it's bright. A lot of the objects are large. There's a lot of detail to see. But there's a bazillion observing lists out there that can really meet just about anyone's observing interests or styles.
Yeah, and I think that's one of the challenges that newcomers can face is, well, what should I look at up there, and where do I begin? Well, I think like we covered, like, first of all, start learning the constellations. That's key. I sometimes will chat with newcomers who have really gotten into like computerized telescopes and stuff, but then they're trying to look for things and struggling to determine exactly what they want to see next because they've been reliant on the technology. Not that technology isn't good, but sometimes they've become too reliant on it, so they're sort of struggling on where to go next. But then for other folks who are really just getting started, like these lists can seem pretty long, like 110 things, and certainly some of those things on the Messier list are reasonably faint. So a lot of organizations, like I know, like in the States, the Astronomical League, and here in Canada we have the Royal Astronomical Society of Canada, and we've put out a program called Explore the Universe or Exploring the Universe. It's one or the other. But if you type in Explore the Universe, RASC, we've put out a free program through the RASC Observing Committee, which I sit on. And anybody can go and download their PDF sheets, and anybody can go and apply to the program. You don't need to be a member of the organization, and you can get these nice pins and a certificate. And what that program does is it actually breaks out. I think it's really just a few dozen different things that you can see in the sky. There's some stars, and there's some really easy to see clusters and a bright galaxy or two and that sort of thing. And it really gives you like a very brief introduction to the night sky and the things that you can see. And there's some other resources at rasc.ca. And like I said, just go on there and look under observing programs, and you'll find Explore the Universe.
Yeah, that's a great suggestion.
Yeah. So charts, how do you find this stuff on a chart?
Right. So here's another reason also to use a list. So when you decide on your list, you're going to have a list of the objects, which is obviously important. Now, what else is important is where they are. So which constellation. So we've already talked about how to find the constellations, but if you're trying to find out where the object is within the constellation or within your atlas, you need to know some details about that object. So the list will have some coordinates for that object known as right ascension and declination. And those will help you locate where the object is within your atlas. Now, maybe before we get into that detail, Chris, what's a good atlas? What atlas do you use? What atlas would you recommend?
Yeah, so if people are just getting started, I really think that Night Watch by Terrence Dickinson, actually, it has a really great basic atlas in there, which I think is all the atlas an absolute newcomer needs. And he draws out the main constellations like Ursa Major, the Big Dipper, Boots, the Herdsman, Leo, Orion, all those kind of main constellations are in there. And really, like a newcomer to astronomy, who's trying to learn the constellations, maybe using the charts at skymaps.com or the HA Ray book, in combination with Night Watch. I mean, you can really probably go for maybe a year or so. Some people might be faster than others. Some people really might want to take their time, and that's great. But then like beyond that, like if somebody, is like, all right, I really want a good chart because I'm really into astronomy now. I think the best getting started chart is the Jumbo Pocket Atlas by Sky and Telescope. They make a Pocket Atlas, which is a little bit on the small side. I think we all bought copies when it first came out. And then they put out a Jumbo edition, which I think is perfect for people who are just learning the skies. And the reason why is that chart actually, one, it's pretty inexpensive. I forget what it costs exactly, but I think it's a very good value as far as a star chart goes. The quality is extremely high. It comes from a very reputable organization, which is Sky and Telescope, and some of the best amateur astronomers out there for creating these type of materials. And then also they draw in the star patterns in there, so that like if you are looking at Ursa Major, you're going to see that Dipper pattern depicted there. It might be spread out across 2 or 3 different pages, but it's still there. So if you've recognized the Dipper pattern of the Big Dipper before, that's going to be in there. Whereas if you bought one of the older star charts, like I know these are a little bit out of print now, like Uranometria, which I do own a copy of. Like there's no constellations drawn in there. And then some of the other charts that have been around for years don't have the constellations drawn in there either. And certainly if people want that experience of just having the stars themselves sort of standalone without any of the lines drawn in, then certainly people can look to some other charts. But what would be a more advanced star atlas that you can recommend, Shane?
Well, one that you and I both own, and I know we both quite like it, is Interstellarium. It's probably generally regarded, I think, as one of the best, maybe certainly like top 3 type of atlases out there.
Yeah.
It's exceptionally detailed. I forget what magnitude it goes down to, but I want to say it's like 11 or something like that. It goes pretty faint.
I feel like it's not that, but
no?
I think
okay.
It's like 8 or 9 or something like that.
Oh, okay.
It's getting down there, yeah.
Yeah, but it's a wonderful atlas with a ton of objects that you'll probably never have enough time in your lifetime to observe them all.
Yeah, I really like the Interstellarium, and I think it also draws in the patterns, which is really helpful. And then there's a lot of material in there, but I think they really struck a good balance. One that is really the cornerstone for people that are sort of progressing is the Sky Atlas 2000. But to be frank, I think the Sky Atlas 2000 and the Pocket Atlas are now almost synonymous. I think they actually use the core information from the Sky Atlas 2000 to make the Pocket Atlas. And then once you get into the Jumbo edition of the Pocket Atlas, I think you've basically got the Sky Atlas 2000 more or less, and I think you've really got what you could have gotten out of the Sky Atlas 2000. I'm going to say this about star charts. This is one thing that most people aren't going to realize, because I didn't realize this. I use software for planning my astronomy classes, for teaching newcomers to astronomy, and I also use them for planning my own astronomy sessions. And when I was first making star charts for these purposes, I quickly realized that you can kind of get lost in space pretty quick, because one of the things that you're paying for when you buy a physical atlas versus just trying to use a piece of software is, in the software you can zoom to any kind of level. You can zoom out and see the entire night sky, or you can zoom right in and make just a double star system or quadruple star system or something fill your entire screen, and that's really cool. But when you get out under the night sky, how does that scaling work? What scale should you have it sent to? And that scaling needs to be fairly accurate, or your eye and your brain won't be able to translate what you're looking at on a page or a screen and into what either you're looking at with your eye on the sky or through a binocular or through a telescope. And so there's a bit of a barrier there when you are using softwares under the night sky, or even like for me printing off star charts. I had one last night. I've got some that are working, and I got one and I'm like, this doesn't work because I've scaled it wrong. And so people do need to be aware for that. But with like the Pocket Atlas or Interstellarium, they've done that scaling for you so that you're not sort of getting lost in space by having these different zoom levels. So I'm not sure if you ever experienced that or not, Shane, but that's certainly something that I discovered, which was unanticipated.
Yeah, no, for sure. And scale is kind of an interesting concept. And I think it's somewhat subjective. I think it varies from person to person in terms of their perception of the sky and then seeing it on paper, but I can definitely relate to that.
Yeah, and it depends. So for example, your fist at arm's length, we've talked about this before, and we do usually refer to it every month. We do our objects in the sky. Your fist at arm's length is approximately 10 degrees spread over the nighttime sky. And then, so if you were to correctly depict the star chart, you would want to have maybe that scale to a certain extent, right? And then it depends on how close or how far away you'll place your eye to the page. For example, and I could be wrong on this, but I believe when I was looking at E. Barnard's Atlas of Selected Regions of the Milky Way, and I printed off a copy when it became available digitally, and then subsequently have bought my own copy of it. When it was reprinted, I noticed that the scale was pretty good for about that kind of same distance, and then other ones you kind of have to bring sort of closer to your eyes to kind of make sure that it matches. But if you're using just a regular piece of software and you're like trying to zoom in on something, it can become really bewildering to sort of match what you're seeing on the screen with either what you're seeing with your eye or through a telescope. That's very difficult, and I kind of meet up actually.
Yeah. No, that's the fist at arm's length is something I use all the time.
Yeah. How about marking up the star chart? So you've decided what you're going to look at. You've got yourself a star chart. Where do you go from there? Do you just take it out with you and look at the sky, Shane, or do you do any kind of prep work before you go out under the stars?
Well, both actually, but I prefer to do a little bit of work prior to going out and mark up my star chart. So what I've done is I purchased some Post-it notes, but like those little arrows that you can write on. And what I do, so before I observe, I'll spend whatever amount of time, half an hour or so, understanding which objects I want to look at. Then I find them in my atlas or on my star chart, and I put one of the Post-it arrows pointing right at the object with the NGC or whatever the catalog designation is. And then when I go out observing, what I love about this approach is all I do is observe. I don't spend time looking at my star chart for the object and then trying to find it in the atlas and then finding it in the sky. And, this is just something actually that I've started doing based on like kind of your recommendation of how you were doing it. And it is so much better doing it this way than trying to find the object in the atlas while you're at the telescope. At least for me, when I'm at the telescope, I just want to observe, and this gets rid of the frustrating, trying to search for something with a red light, on a piece of paper.
Yeah, and like right now, I'm looking at a set of approximately 50 things in the nighttime sky spread out over a constellation, which is spread over maybe 6 or 7 pages on my atlases, and it would be daunting to go out there just with a list, and then you're looking at the list, and then looking at almost like this sea of objects in your paper. It would just, to me anyway, I would just be overwhelmed by that. To try to do it in any kind of efficient pattern. I'm trying to do this over the course of a month or so, and but if I was just to go and try to pick these off one at a time, I think it would just be so difficult. But look, one of the other things I want to mention, and I don't know if I mentioned this to you or not in a recent episode, but I actually used the wrong color ink when I was marking up these charts for this.
Oh, jeez! So you couldn't see it.
And so at night, we use red lights. This is another thing that we haven't mentioned, but we're sort of talking about finding stuff. But using a very dim red light is important so that you preserve what's called your night vision. So during the day, your eye will constrict, your pupil will constrict and let in less light because there's lots of light around. And at night, that pupil will open up. Now, if you're out at night and you're looking at a star chart and you use a white light, that pupil will constrict, and then it takes about 15 minutes to half an hour for it to open up wide enough to really see all the stars again. And that's something that also newcomers face as far as a challenge. So you can actually go and buy these astronomy flashlights. Typically, they're between like say $20 and $40, which can be a bit of money. So typically, what I recommend for people to do, and this isn't the best if you really stay in astronomy, but it certainly will get you really far in astronomy without having to shell out so much money for a red LED. But just get an inexpensive red flashlight and put some red duct tape or red electrical tape, or paint the lens red, or use a pill bottle cap. If you have a pill, I have a pill bottle cap here that's red that will fit over a flashlight. You can use all kinds of different things to dim it and make it red so that your eye isn't dilated by or isn't constricted by white or really bright lights when you're under the night sky.
Yeah, for sure. Controlling that light is super important.
Yeah. And what I did is I used a color ink that was invisible under red light at night. I didn't know that. I grabbed a pen at random and I'm like, this is invisible ink at night. In the day, it looks totally fine. So I actually had to go through with a black ink pen, and I just went and inked them all again in the warm afternoon sunshine so that I didn't get the ink everywhere on my star charts. But yeah, I mean, my star charts, I will never be able to sell them. They are marked up. I've got sticky notes, but they're battle scarred for sure. They're going to be well used.
Yeah, for sure. So what's next in the process, Chris?
Well, one thing you talked about, we sort of made these notes up. We're gonna sort of do one thing, and then we switch gears right at the last second. And I really like what you said about using your binoculars. And now we've talked about binocular astronomy a lot in the past, but binoculars really get you more than halfway between what your eye sees alone and what you see through the telescope. And binoculars are great because they make sure everything is right set up and correctly oriented, where the telescopes are typically going to be turning things around quite a bit. Mirror reversed, upside down, all this kind of stuff can make things a challenge to find. So like you were saying, what you can do is you can find stuff with the binoculars first and then find it with the telescope. So particularly like anything that would be like in the Explore the Universe program, which is a free program by the RASC, which is a volunteer organization that we belong to. Typically anything in that program you can see with your binoculars first, and then you can actually use that to kind of guide you when you're pointing the telescope to that region of the sky. I do that a fair bit. I think you do that as well, Shane.
Yeah, for sure. And I did it a lot more when I was first starting out, because like you said, the telescope can change the orientation. So like a Dobsonian, left, right is reversed and up, down is reversed. So to do the mental gymnastics in your head of trying to match the star chart to what you're seeing through the eyepiece can be a little challenging, especially if you're tired and you've been observing for a while. Mm-hmm. So sometimes just getting the star field in the binoculars, because everything is as it appears in the atlas or your star chart, just makes it a lot easier than to go to the telescope and kind of say, oh, it's left of the bright star over here.
Yeah. No, that's really good. One of the other things that people can do, and I really like using the binoculars quite a bit because they're correctly oriented, and it makes, again, like you said, that you don't do the mental gymnastics, but you can get finder scopes that will correctly orient the image for you. And so I've had these in the past, and I've recently rolled my own, which costs a fair bit more than just buying one off the shelf. I think you can buy a pretty decent one off the shelf for probably like $50 or $60 or something like that.
Yeah, that sounds about right.
And they just simply mount on the telescope. Typically, there's ways to mount these finder scopes on whatever telescope you have, and you can get one of these correctly oriented finder scopes and see if it's for you. Now, some people. I know like one person who's pretty famous in the amateur astronomy community is Ed Ting, and I was watching one of his videos. He does YouTube videos now. He's been around in the astronomy community since long before YouTube. But he was saying like he prefers the straight through version. And I guess there's a couple different types of finder scopes that people can actually use on telescopes. So sort of what are the main two types? What are the main two types of finder scopes, Shane?
Well, I would think I would boil it up to a high level of there's optically aided finder scopes and then like non-optically aided in terms of magnification, like a one times and then a multiple times finder.
Yeah, like a zero power finder, I think they're sometimes called. Though I think you're right. I think it's more like a one times finder, and then ones that actually will be like little refractors all on their own, or something like that. So, do you use any finders at present, or have you used any finders in the past for helping locate things in the sky?
Yes and yes. So when I first started off observing, I kind of had a three-stage approach to finding an object once I was at the telescope. So number one is I would use one of these like zero times or one times. It's basically like a red dot finder or a reflex finder. So
Yep.
I was using a Telrad, and what it does is it imposes like some rings in red, and you can control the brightness. And when it's aligned, you wherever these rings are pointing, that's what your telescope is looking at. So I would use that to get me into the general field. Then I also had I think it was a 7x50 finder, like optical finder on the telescope. So then I would use that because it gave me a pretty wide field of view. I would use that to get me kind of more into the star field that I needed to find my object. And then usually in the telescope focuser, I would have a bit of a wider field eyepiece that would allow me to see the object or find it then, hopefully with relatively little movement at that point of the telescope.
Yeah.
And then if I wanted more magnification, I would use more magnification. Now, what I do use quite a lot, actually, though, still is the red dot finder. I just love how quick you point the red dot at whatever star or planet that you want to observe, or at least start star hopping from. And it just is so fast. The acquisition is quick, and I love it.
It's basically like an advanced sighting tube, really, is what these are. They're the better part of an inch across. Usually they look like a little tube, and then they have a little red dot that gets projected onto the screen, eh?
Yeah. And the power consumption is like next to nothing. Like I leave these things on all night, and I don't even know if I replace a battery once a year. Like they do a really good job. And again, you can vary the brightness. So if you're in a light polluted area, like within the city, you may want it brighter so that you can actually see the red dot. But then when you're under a dark sky, you can tone it way down so that it's not, blinding you almost when you're fully dark adapted.
Yeah, and they often come with beginner telescopes. Although I got to admit, I bought a couple over the past year for beginners, and I didn't give them because some of the really inexpensive ones are improperly constructed, and they have the plastic screens or the glass screens lack the opacity and lack the functionality. And it was very difficult to actually see the stars through them. And I thought, well, I'll just instruct them to use super low power eyepieces. So if you are getting one, get one from like a reputable telescope store. Make sure that it's one that isn't just necessarily included with a telescope, like a really inexpensive telescope, like some of the ones I was getting. Get a proper one, and I think a really good one would run about like $39 or $40 or something like that. And definitely like the Telrads are still out there, and the Rigel systems are still out there, and those are sort of the original red dot finders. But yeah, it just allows you to have a red dot in the sky, and basically whatever you see with your eye, like you learn the constellations like we talked about earlier, and you can just point it at a particular star or area of the sky where there's a deep sky object, and then that'll be centered in your low power eyepiece, like Shane said.
Yeah, exactly. So then when we get into optical finders, Chris, there's definitely some variations there as well. Do you want to take us through some of that?
Yeah, one of the things that I notice with folks is they often get focused on having a bigger and bigger finder. That's very common to hear in amateur astronomy circles, and I think that people maybe just haven't fully thought through that. So with the finder, what you're doing is you're placing the primary telescope into a position where it's going to be on whatever it is that you're looking for, which is typically going to be fainter than what the finder sees. So you want to get a finder that has a really high quality wide field of view, whether it's straight through, zero power, or maybe a more advanced finder. So, for example, my advanced finder and finder scopes will come in, I think you get them in like about a 20 or 24 millimeter size. Aperture size, a 30 millimeter is pretty common. 40 and 50 millimeter are common. Then you can get them all the way up to like, I think 3 or 4 inches. But I think probably the most useful ones are sort of in that 30 to 50 millimeter size range. And so I've recently sort of rolled my own finder scope of 50 millimeter in size. And it's an optical finder, and it has what's called an Amici prism in it, which is a correctly oriented. It's right side up and correct left to right, just like a pair of binoculars. And then with this one, I can actually use any eyepiece I want. I can actually use any eyepiece in it that I want, which is something that I always wanted to have. And what that allows me to do is have a super wide field of view. And I think that is one thing to focus on a little bit more than any of the other aspects of a finder scope, is just having a high quality and pretty wide field of view. And again, many of these can be purchased off the shelf for around $50 or $60 or so, and then you'll be able to look through them. Now, the advantage of rolling your own is you can use all of your own eyepieces, and I like to have, or I need to have, long eye relief because I wear glasses at the eyepiece, and I just want a little bit more control over how wide a field I have just for some of the objects that I'm looking for. It can be pretty challenging to see in my small 4-inch telescope. But sort of like, speaking of telescope, Shane, you said use an appropriate telescope. What did you mean by an appropriate telescope?
Did I say that? I think I meant maybe like using was it an appropriate eyepiece, like a wide field eyepiece in the telescope?
Okay, maybe that was it. Yeah, sorry.
Yeah. No worries. I wanted to make sure we were on the same page.
I'm a little tired, so
yeah, that's what
I stayed up all night last night. It turned out.
Yeah. So like having a wide field eyepiece in, like, really what we're talking about here with all of this stuff is kind of increasing your success of finding an object, because it's not always easy when you're manually trying to locate them, but it's extremely rewarding. I love the kind of the hunt, or trying to find this stuff. And you're just trying to kind of slowly narrow down the area of the sky that you're looking at. So you start off with like I say, like the red dot finder, which has no magnification. It just gets into the general area of the sky. Then you could go to an optical finder, which allows you to maybe star hop or see some fainter stars, which again point the telescope closer to where this object is that you want to find. And then you go to the telescope with a higher powered eyepiece, but hopefully still a wide field of view, so that it makes it easier for you to see the object. Because if you have a narrow eyepiece, and the object is, just outside of the field of view, you're not going to find it, and you're going to keep scanning around and maybe get frustrated. But a wider field of view allows you to just see more of the sky through the telescope, so you're more likely to find this object. And then once you find it in the telescope, you center it, and then you could put different filters on. If you're looking at nebulas, you can do different magnifications to see if you can pull out more detail. That's when the real observing begins.
Yeah. One thing I want to mention is like go-to telescopes, which are pretty popular. I'm going to mention go-to telescopes and then let you talk about the right ascension and declination. But with the go-to telescopes, and even my telescopes can be set up as go-tos. The challenge can be that with many of the things that we're looking at, they're at the threshold of vision. So people might be listening and say, well, why wouldn't I just buy a go-to telescope? I set it up, I go through that process, I punch in some numbers, then it goes to the stuff that I want to see. So the challenge with that is most of this stuff is going to be really faint. There's a handful of brighter things that you can do that with. But for example, I was looking at a planetary nebula that's just 8th magnitude. That's a pretty bright planetary nebula. And I was hunting it down using my right angle finder scope and my 4-inch refractor last night. And if I just simply punched it in, there's no way I would have seen it. I'm an experienced amateur astronomer. And sometimes what I do when I align my telescope is I will actually, like, as it's getting dark, I'll actually punch in something. Last night I punched in M4, I could not see. I couldn't see it. Maybe if I had hunted it down, I would have seen it, but it was just too bright. The sky conditions weren't right. So there's some other challenges than simply just buying a piece of technology, punching in some numbers, and then being able to see it. And I think that's what we're talking about here, is that there is this process. Whether you want to follow it or not, you're going to end up having to learn this process as part of doing amateur astronomy. This is sort of the love of doing it. This is that process for actually successfully finding that stuff. Because, and I know this, is that I get hundreds of people showing up for my astronomy class over the past few years saying, I bought a GoTo telescope and I can't see anything through it. And I'm like, and they're often great telescopes, really good optical telescopes, but to actually see the stuff, you need to go through a little bit of a process here. And again, like, my telescope has GoTo functionality, but when I'm trying to find a lot of things, I'm not using that functionality at all. In fact, I don't really use that GoTo functionality. I use it for tracking and getting on some other targets. Maybe once I've located them, maybe as the conditions are getting darker, I might go back to a target or something like that. But that's really how it works. But Shane, going to let you talk about right ascension, declination. Those are the coordinate systems for actually finding stuff. And how do you use right ascension and declination? What do they mean? And how do you use them for finding something like, say, M31, the Andromeda Galaxy?
Yeah. So right ascension and declination will be listed for objects, like on an object list, or like if you look up an object in planetarium software, it will list the RA, or right ascension, and the declination, usually abbreviated DEC. Now, what you do with that information is you go to your star chart or your atlas, and these are just like maps that you would, like a topographical map, for example. There are coordinates on your star chart on the outside edges, top, left to right, and then on the sides, top to bottom. And that is your RA and your declination coordinates, so to speak. So if you are looking for, I don't know, M31, I don't have the coordinates right in front of me.
That's
where are they? Oh yeah, here we go. So the coordinates for M31. So right ascension is 42 minutes, 44 seconds. Declination is plus 41 degrees, 16 minutes, 9 seconds.
And it's in the constellation Andromeda.
Yeah. So what you would do on your star chart, you'd find out where Andromeda is in the atlas. And then
just flip to that page.
Yeah. Flip to that page, and then along the side, you'd look for where's roughly 42 minutes. Okay, hold your finger there. Now look on the other axis and look for 41 degrees, because that's the declination, and then just basically kind of draw almost straight lines. Like, there's a little bit of curvature, and there's some guidelines in atlases that show you that, but you basically connect your fingers, and that'll get you probably right on Andromeda Galaxy, or at least very close. And then in the atlas, you're now looking for M31 in that spot. And now, once you found it, now you can go to your telescope and find M31 in the sky.
And since you touched on it, I'm going to get you to describe Mercator projection now. I'm just kidding. I think that's what the curvature is called on the charts. Anyway, but yeah, I mean, that's a perfect way to describe it, is that you find out what constellation the object is in that you're looking for. You find that set of charts on your atlas, and then you use just that RA and DEC, like make that right angle connection. And then usually whatever you're looking for, like most things, like 99.9% of the time, they're going to be plotted on that chart if you're using the appropriate chart for the stuff that you're looking for. If it's not plotted, then you're in for a bit of a challenge. Typically things that you can see are going to be plotted on the chart. But I think that's a great explanation, Shane.
Yeah. So, I think with everything we've said here, starting it off like right at the very start, like talking about lists and where to find the objects you want to observe, some good beginner books like Night Watch, then some, atlases, and, this is the process to finding an object with your telescope, right? Beginning to end. And we're probably missing some things, and everybody, I think, has or develops their own approach. But this is a pretty solid guide, I think, that will help get people going. And even me, who I've done this now for almost 2 decades. just this year, I started to mark up my atlas with those Post-it notes. So, you can always learn, I think, some different methods too that can improve your observing, even if you've done it for a while.
Yeah.
And, for me, it's all about just maximizing my time at the telescope and seeing as many objects as I can.
Yeah. And I have to stress this process, the finding of stuff, this really is the rewarding process, and then the observing of whatever it is that you found, that's sort of like the other half. But that discovery process is in many ways, that's the thing that kind of keeps us coming back and keeps us looking through the telescopes, because there's not as many things, but in life where you can actually look at sort of that original article. If you're looking at a Hubble Space Telescope image, well, sometimes the things are going to be too faint, but a lot of the stuff you can actually see for yourself. It's going to look different, but a lot of these stuff with a lot of things that we look at in these natural sciences, we can go out and see for ourselves. And then again, like with astronomy, I was looking at X off Yuki last night, and I was too tired. I didn't quite get the observation down good enough, but you can do a variable star estimate and submit it to the Variable Star Association, AAVSO, and that will contribute to the greater body of science. So it's sort of like one of those few things where you can be doing that in these natural sciences. Very cool.
Yeah, for sure. And with that note, Chris, I think it's probably time to sign off.
All right. Well, I'm going to go get some sleep.
Yeah, you should.
Right. Now that my batteries have been replaced in my detector. All right. Thanks so much, Shane.
Thank you. Thank you, everyone, for listening, and we hope you enjoyed the show. If you are interested in more information, would like to contact us, or if you would like to support the podcast, check out our website, actualastronomy.com.